I've had a ton of questions about containers. I've had a ton of questions about DevOps. And so the natural question is, why the heck aren't these things on the exam? Because, as we're talking about them, we're saying, well, they're not on the exam, so you don't have to worry about it. But as an architect, you need to understand these technologies. So I thought it was really important that we go through the process of teaching you about them. One, I think eventually it will land on the exam, but the exams tend to be a bit behind the technology because we're not actually working on the exams while it's in preview. We don't work on the exams until we know what's actually going to be in production. Also, a note on the exams, the people that are building the content don't have access to the exam questions. So we're going off what was on our exam whenever we took it. Like in my case, it was like over 3 years ago. Like I was like, as soon as it came out, when Ian was up here, he actually took the beta version. So he took it before the exam was actually out. And the questions that are on the exam are constantly updated with new technology. We can surmise by taking all the exams that we ultimately end up taking what's going to be on this exam based on understanding what the exam objectives are. And that's really, when we're writing content, that's what we're going by, is that we know these are going to be on the exam, and then we know the technology, so we kind of know what's most important in those technologies whenever we actually go to use it. So we can surmise exactly what's on the exam. But the questions will definitely be different on the exam. Anyway, containers are not on the exam yet. At some point, I'm sure they will be. But I did want to give you a crash course. Now, in 15 minutes or so, I'm not going to be able to give you a real deep crash course on containers. So what I want to do instead is I want to get you an overview, a high-level view of what containers are. And the way that I'm going to do that is I'm going to compare and contrast that with other technologies that you may already be familiar with. The first one is session-based computing. Session-based computing, most of us know, is terminal services or remote desktop services. And session-based computing has some awesome technology. It's been around for years. It's been around for well over a decade. It's been around forever. It goes back to the terminal services days. And it allows you to run a desktop environment for your users, and a lot of them all at once. So you have a server sitting back in the background, and all those applications are installed on the server, and your users are just logging in and they're getting a kind of a private shell of that server. The beauty of this is, let's say that we have a piece of hardware that is, let's call it, a 12-core machine with 512 gig of memory, and some fairly decent performing drives, whether it be SAS, 15,000 RPM drives, or maybe even you've got some SSDs in there. You can get a whole bunch of workloads on there. When you're considering a workload as being a user that's logged in and using that as their desktop, you could easily get 250 users on that environment, right? Very easily. Now, of course, it depends on what their workload is. If they're running database applications or CAD or something like that, probably not the best fit. But for most office-based workloads, very, very high. Very high utilization. The thing to point out here, though, is you have a single OS for all those workloads, right? Windows Server, under the covers, or all of those users are standing on the same operating system. When we look at how does that compare to VM or VDI-based computing, and I really lumped VM and VDI together. VDI is a desktop for an individual user, but its underlying architecture is just a VM. Maybe there's some extra perks, extra bells and whistles that are on top of that to manage that VM, to start it, to stop it, to do the dynamic allocation and pooling and stuff like that. But fundamentally, it's using the same technology. VDI uses VM technology. The difference, if we contrast this, how that runs is in both of those scenarios, an individual workload is inside of a VM. The user is logging into a VM. They're not logging into the host. An application is running in a VM. It's not running on the host. Okay? What that means is you have a ton of overhead because you have an OS for each workload, and that gives you the overhead of the OS, the apps, the config management for each of those workloads. This is a massive overhead. Massive overhead, because you've got to look at the disk I/O, the memory, the CPU, the OS, the licenses, the density, everything. What do we mean by density? That same server I can fit 250 users on, 200 users easily? How many of these VMs could I fit on that? Right? Significantly less, 25 if you're lucky, depending on the size of the workload. Right? Significantly less. Why is that? What is Windows doing when it's not doing anything? A lot, right? A lot. And if you got 3D screensavers on, it's doing a whole lot. So you've got to look at all of the things that are happening under the covers, that OS is always running. So it's always spinning those disks. It's always writing logs out. It's always consuming memory. It's always doing cleanup. It's always doing stuff. And of course, if users are using it or the applications are being leveraged, it's doing a lot more even. So the amount of density that you can get out of that server is significantly higher with session-based computing. By the way, back on session-based computing, just one more thing I want to highlight on this is, I talked about managing all those different things. What are you managing over here in session-based computing? You're installing the application once for all those workloads. You're managing, you're backing up, you're doing you're monitoring one time for that one server, right? So it really is a huge difference. So let's move on to containers. So now we understand what session-based computing is, we understand what VM and VDI is, and we understand kind of how they compare and contrast. Okay? There is a reason for VMs, and there is a reason for VDI, but they're specialized in that case, just like session-based computing is specialized for a particular case. So let's look at containers and how they work. Well, in a container, you have the hardware, you have the virtualization, you have the operating system, same as you do in the other platforms, right? Whether it be session-based or VM-based. And instead of having a virtualization engine, which you might actually have a virtualization engine in there as well, you have a container engine. That container engine is managing the containers that you put on top of it. On top of that, you have a container image. Now, the image has to be similar to the operating system that you're running underneath it, but you have, just like session-based computing, you can add a bunch of containers to that. And a bunch of containers, you'll hear in a few minutes, in my next session, about a little bit more about how the different workloads work. But in a container environment, each one of these different containers are different applications. They are different workloads. But how many operating systems do you have? You still only have one operating system. That is your host operating system. So you get all the advantages of session-based computing in that respect. But let's look at it from another standpoint. What if I have a container-based computing with VM isolation, right? So in this case, on half of my machine, I stand up the container environment. I run my applications on top of those containers. But maybe I want to run Linux on top of that host. So I can run Linux containers also, right? Most of the container images that are out there are running Linux now, so it's not a far stretch. And same scenario, I just run my Linux VM. I set the container engine on top of that, and I run whatever apps that I want. In this environment, I have a single OS per platform. Still significantly better than a VM-based technology. Let's take it one step further and look at, you get all the advantages of a VM and the advantages of session-based computing. Okay? So you have isolation. Each one of those containers has its own level of isolation, but as you break it down, and I could have also shown this as the container not running on top of the operating system, but rather running inside of a virtual machine, right? And then the container's running on top of that. So there's lots of different ways you can run it. We'll talk about that in a moment. So let's talk about deep containers, going deep into the architecture of what's actually going on. This is an architecture class. This is an architecture slide. This is not meant to be for people that are pushing buttons to make things happen. It's really understanding what's going on under the covers so you can understand how to leverage this awesome technology. So just like the other scenarios, you have the hardware, you have the hardware virtualization, you have the operating system, okay? On top of that, you have your container engine, which we talked about. That engine could be Windows, it could be Linux, it could be Docker, okay? Well, let's talk about that just for a second. What do you mean it could be Windows? What do you mean it could be Linux? I thought the engine was always Docker, right? That's what a lot of people think, but no. Docker, what Docker leverages is the underlying operating system's containerization capabilities. Linux has had it for a very, very long time. It never really became popular, and we'll talk a little about that in a second. And then Microsoft, with Windows Server 2016, added containerization capabilities. We'll go deeper into how you can enlighten other capabilities like Azure in a moment. But there is this engine piece. Docker created their own engine, but that's not what made them great. What made them great is the fact that they have this orchestration piece, this container orchestration piece. But most importantly, they have the hub, the application hub. So they did what for containers that have been around for years in Linux, they made it very easily consumable through orchestration and the store, the hub. So let's look at this from a business standpoint. Let's say I am Sage, or a division of Sage, maybe Sales Logics or whatever, right? Where I have this solution, a minimum viable product, maybe $30,000 for an enterprise customer, right? In order to set all of that stuff up, I have to have engineers go on site, deploy a bunch of software, do a bunch of database configurations, do a bunch of customization, a ton of stuff. To get them to even evaluate my system would cost $30,000, right? Because there's a lot of work in that. Look at what containers can do. I can do a pre-configured container, already configured, say, one for financials, one for insurance, one for, maybe I'm even going to do retail or whatever, right? Whatever market I wanted to serve, I could do a container specific for that market. And I can make it very narrow. I can make a container for gas stations, convenience stores, right? That I can sell directly to a market that I didn't have access to without containers. I'm opening up whole new markets for my goods and services that I didn't have access to before. And all that is possible because I can download those. I can build those images one time. The beauty of containers is you build it one time, replicate it anywhere and everywhere, right? And you can do it very, very cost effectively because I can create those models that are good for most. And then, of course, you can add the additional customizations on top of that if you want to. And we'll go more into that in a few minutes. But what happens is whenever you build out that image, you're building it on a base OS image. That OS image, like in this case, we're using Nano. So that OS image is going to be from Microsoft. It's going to be, you're going to go to the microsoft.docker.io, which is the hub where you can download images. And then on top of that, you'll have maybe a base image, a web engine base, maybe IIS installed. Maybe you'll install, because you can download that at the IIS level, and you can just download and start with there. Or you can download Nano with nothing on it and install IIS on it yourself, right? And then at each layer, you can save, or you can keep building, right? So I could save my own IIS image if I wanted to. Let's say that I'm going to do that, and that's my standard IIS image with all my corporate changes embedded in that image already. But then I want to go ahead and configure the web engine, right? This is not all machines, but this is this group of websites that I want to have on there. So I have a web engine config, right? And then on top of that, sorry, I'll come back to this in a second. On top of that, I can build my websites. But what I want to point out here is each one of these blocks are different containers. So containers are built on top of other containers. And you can save them at any point. And this is what is awesome about containers. It uses a copy-on-write technology. The upper layer, the highest level layer, is always in write mode. So if you make changes, say I make changes to the operating system configuration for Nano, but I'm at my website layer. Where does that change go? It doesn't go into Nano. That would be bad. That configuration is stored in the IIS container because that's the container that I'm writing to. You're only writing to the top container. And those can be saved. Whenever they're saved, they're locked. You can no longer write to those. That doesn't mean you can no longer use them. That means as soon as you write to it, it's going to build another layer automatically. And then you're going to be writing to that top layer, okay? And any one of these workloads can be saved as a base image. So I have my nano base. I have my customized nano base, right, where you have maybe it joined to, maybe you have the certificates on it to do authentication or whatever. Actually, that's probably a bad example. But you have your own management. Maybe you have your agents for Ops Manager or whatever, whatever things that you're doing for all of that stuff going. And then you could have your web engine, right, that has in it, for my web engine for this, I want it to include PHP capabilities as an example, right? You can have that built into that container. And then whenever you want to build another container, you can use that as your base. Or I've got a website, I want another one exactly like it. I got another one, that I want 10,000 exactly like it. I got 10,000 that I want to run like that. How many operating systems am I going to have? This is where it gets really, really, really cool. How many operating systems am I going to have? One. I've got my base operating system. On top of that, I have my base OS. So the base OS is nothing more than a write container. Actually, it's not even a write container. It's a saved container is a known state. So that's going to be version X.Y.Z, right? And then whenever I build on that, I'm going to be saving it in the container above. The beauty of this whole system, though, is as you roll that up, you can save at any point. And not only can you save, but you can redeploy. You can redeploy to another location. You can move to another location, right? You have some pretty incredible capabilities. Now, the engine orchestrator, I have the orchestrator over here on the left, that allows for you to do awesome things. You can move it around, you can start it, you can stop it, you can save it, you can update it, you can do whatever. I can also have a different website. Right? I could have maybe on the first one I have 50 websites, but I want a standalone website, right? I'm going to put that in a separate container all by itself. I can also have other apps that are running, okay? Doesn't necessarily, in these apps, I could be showing these right on top of the container. I don't have to show them on top of IS. It could be at any level there. I could add those additional apps or websites or whatever. I could add different configs, right? I could have different configurations. I could have different web apps. I could have different even more configurations and even more apps with different capabilities. And all they are, each one of these blocks, completely isolated. Each one of these blocks cannot write to anything below it. Right? Very, very cool technology. So if you think about how this works when we were talking about the session-based computing, you have all this portability and all this configuration capability in a very neat, easy package to manage. Okay, how containers run. You have the host, you have the hypervisor, you can run the Linux virtual machine, run Docker inside of it. And again, Docker is generally your orchestration engine, but it does now have a Docker engine that you can use, like you can run Docker. You can run Docker on Windows 10, Docker engine, or you could run Windows containers and have Docker manage it for you on Windows 10. And in fact, Windows 10, and Windows Server 2016, the containers that are built in there are done with a partnership with Docker. Most of the commands are exactly the same. The only exceptions that I've found are like in Nano, where there's some things that Nano won't do, like IT. IT is an interactive session. So the -IT switch doesn't work in Nano because it doesn't have that interactive capability because it's a non-graphical interface. So you can run those in a Linux virtual machine or Windows, whatever that may be. You can run Windows Server containers. Windows Server containers are built into the operating system of the operating system. They can run inside of a VM as well. You can run Hyper-V container in a virtual machine. So that's using nested virtualization. You can have a VM that's running containers. Hyper-V containers are containers that lay on the hypervisor. They're super fast. The big difference with Hyper-V containers is, again, none of this is on the exam yet. Maybe it will at some point, but maybe not. I don't know. Hyper-V containers give you the capability of including the kernel. One of the disadvantages of containers is you have a shared operating system. That means you have a shared kernel. Right? You got all these different apps. Yeah, you're not repeating the operating system. You're not running multiple operating systems, but that comes at a cost. It comes at a security cost. in those environments where you cannot use a shared kernel, regulatory requirements or whatever, you can't run a shared kernel, Hyper-V containers come to the rescue because they have the kernel built into the container itself. So the enterprising person might say, but Dan, that's just a VM. No. The reason why it's not just a VM is because you have all of the other capabilities of containers. You can build and you can stack, you can save, you have the portability that you don't have out of a virtual machine. Yeah, virtual machines are portable, but not like containers. They can't be built, they can't be distributed like containers can. So you get all the advantages in this environment with Hyper-V containers. You get all the advantages of containers with the added security or taking away the security deficit, if you will, of a shared kernel environment. You could also run, obviously you can run virtual machines on that. You can run Windows Server containers on the OS itself. You could run Hyper-V containers directly on the hypervisor. But the one that is important and will eventually be on the test for sure is Azure Container Service. Azure Container Service abstracts all of the complexity of all that hardware that needs to run the container and delivers it as a PaaS platform service. So very, very cool. You can run Windows, you can run Linux, it doesn't matter. Speaking of Linux and Azure, Microsoft is very, very, very open company now. I know it hasn't always been that way, but as you look more and more into the Microsoft offerings, Linux is truly being treated as a first-class citizen. I mean, literally first class, not second class to Microsoft, but first class, as in many of the engineering departments have a mandate to develop for Linux first and then port back to Windows, right? Literally. So Satya's made some really substantial changes into the way the organization is run and how the technology is deployed. So you'll often see things on open source before you see them inside of our products. Windows containers can run on Windows 10 and Nano too. So there's containers built into Nano.